Okay. Now, now the thing is that how it was invented. What I was telling, that Russian botanist actually was trying to separate different one plant extract from a certain plant. He got a extracted product, and he was trying to separate the component of that plant extract by a solid column. That column was filled with some a glass column was there. It was filled with some solid calcium sulfate or something like that, and he flow that a plant extract through that column, and after certain time when that plant extract was traveling through that solid column, he saw some beautiful ring inside that column, different color like yellow or green, like that, different color he found. So he understood from that the different component from the plant like chlorophyll, xanthophyll, etc., were separated. And this was an old research for last few years. So suddenly he understood that by this technique, the plant component can be separated, and the plant component was separated. So that was the invention of the chromatography first in 1906, and that was the reason the technique name is so chromatography, because he found that color substance are separated by this technique. So he or that person gave the name like chromatography. But the thing is that nowadays chromatography is not only confined with separation of the colored product only, but nowadays even it can separate a complicated mixture of colorless compound also. So the thing is that we can say it is a powerful separation technique. So what is the meaning of powerful separation technique? Powerful separation technique means it can separate the component from a very complicated mixture also, like a plant extract. Plant extract contains so many complicated mixture containing 60, 70, 80 or more than 100 sometimes different type of component. That component can also be separated by chromatography. Okay, so this is the first and foremost important thing about chromatography you have to remember. Basically, it is a separation technique. There are so many separation techniques, liquid extraction is there, centrifugation is there, solid extraction is there, like that. So many different techniques are there, but among that, one of the best and very useful or efficient powerful technique is chromatography. So the separation of component from a mixture of component is a qualitative analysis. You know, analysis or analytical technique are two types: qualitative analysis and quantitative analysis. So qualitative means that is related to that analysis which is related to certain quality of the component. So definitely it is this type of analysis is useful, or it is involved in the separation of the component. So that's why it is coming under qualitative analysis. So it is a separation of component. But nowadays chromatography is one of the most useful analytical technique even in pharmaceutical industry, that is for performing the assay of the compound. So assay, performing the assay, determination of percentage purity, etc., are type of quantitative analysis, because we are determining the quantity, amount present, or percentage purity. All these are quantitative parameter. So that's why chromatography can also be used as a quantitative analysis also. But this is one application of chromatography. This is the modern abbreviated application of chromatography. This quantitative analysis or assay, that means determination of the purity, assay, these are the abbreviated application of chromatography. But basically chromatography is a separation technique, that you have to remember. Next thing is that two important terms are there in chromatography. I think you remember. One is the stationary phase, another is the mobile phase. Stationary phase means the column or the coating on the theoretical or that solid plate or the TLC plate, or the in the paper, the moisture contained in the filter paper are the example of stationary phase. So stationary phase is station, it cannot move, that's why name is this. And mobile phase means which is movable, either liquid or gas. Any type of liquid, maybe organic solvent, inorganic solvent, or a mixture of that, as well as certain inert gases like that hydrogen, helium, nitrogen, etc., single or in a combination, are known as the mobile phase. So these two important phases, stationary phase and mobile phase, are the most important thing in chromatography, basic requirement of a chromatography. Without these two phases, chromatography cannot be performed. So now let's see the definition. Chromatography may be defined as the method of separating a mixture of component into individual component through equilibrium distribution between two phases. That means the component to be separated, they are distributed in two phases, and by which they are separated. There certain portion is distributed in the component which is to be separated, distributed, certain portion is distributed in stationary phase and certain amount is distributed in mobile phase. So like that, by that interaction, mutual interaction, the components are separated. Now let's see, there is a discussion about the stationary phase. I'm not going in details about this stationary phase. The the nature, it is immovable, and one important thing you can see, it try to retain the component along with it. That's the one important thing you have to remember. Stationary phase always trying to keep the component along with that. Okay, that means it is trying to pull the component. Next, another important thing is that separation takes place on the stationary phase. Like in HPLC, separation takes place in the column. So column is an example of a stationary phase. So stationary phase may be solid or liquid. Sometimes some liquid is coated specifically in the stationary phase also. That means in the column. Example, solid adsorbents like silica gel, Kaizel good, alumina, etc. are the example of stationary phase. What is mobile phase? It is movable. What is the thing? It carries the sample along with it. So major role of the mobile phase is to carry the sample. So it tries to carry the sample along with it. Mobile phase is trying to carry the sample along with it, whereas stationary phase is trying to keep the sample along with it. This is another pictorial representation how the component are separated. Okay, I will come later in this. So now let's see, there may be a liquid or gas. Mobile phase may be either liquid or gas, means which is movable, because solid cannot be is a mobile phase. What is the example? Example of the mobile phase is inorganic solvent like water or mild acid or bases, sometime ethanol, or organic solvent like ethanol, acetone, methanol, acetonitrile, etc., etc., and the inert gases like oxygen, helium, nitrogen, etc., either combination or in separately can be example of the mobile phase. Now, so here important thing is that, so component are carried by the mobile phase, they are passing through the stationary phase, and during that time stationary phase is trying to pull the component. So there will be a tug of war between stationary phase and mobile phase. So by that tug of war, who is the deciding factor? Deciding factor here is the nature of that component, that we will be coming later, just after this only. Okay, so that deciding factor, that means the physical characteristics of the component is the deciding factor, how or how long they will be staying with the stationary phase or mobile phase. So very simply you can imagine, or I can tell you in a simple way, if the component having more affinity towards mobile phase, it will travel faster. If the component having affinity more towards the stationary phase, it will travel slower. That is the very superficial one explanation how the components are separated. Okay, we will be coming later little bit more details. Before that, you can see the types of chromatography. We can classify the chromatography in different aspect. There are a different type of classification. At least 4 or 5 types of classifications are there. Number one, you see, based on the different techniques. Based on the different technique, what are the name? Paper chromatography, TLC or thin layer chromatography, column chromatography, high performance thin layer chromatography or HPTLC, which is very important for phytochemical analysis, HPLC or high performance liquid chromatography, gas chromatography, and UPLC ultra performance liquid chromatography. So these are the different techniques. Based on the techniques, these are the so many different techniques are there. But you know, among these, most important is this high performance liquid chromatography. HPLC is most important in case of pharmaceutical applications, and along with GC is also very important and very sensitive. But definitely, pharmaceutical applications are less. Number two, based on the combination of stationary phase and mobile phase, how many combinations may be possible? You see, gas solid. This is one type of gas chromatography where gas is the mobile phase, solid is the stationary phase. But actually, it is not in use. Theoretically possible, but practically obsolete, almost obsolete. Gas liquid chromatography. Next is gas solid chromatography. Next is the gas liquid. Next is the gas liquid chromatography. That means that major example is the gas chromatography itself, GC. So modern gas chromatography having the combination of gaseous mobile phase and liquid stationary phase. How the liquid can be a stationary phase we will be discussing later. Next is the liquid solid. Liquid solid means when liquid is the mobile phase, solid stationary phase. Example HPLC, TLC, etc. Where solid or adsorbents are used as a solid stationary phase. And liquid chromatography like HPLC, paper chromatography, etc. Where mobile phase ক্লাসে আছে একটু ক্লাসে আছে একটু পরে করছি আমরা ঠিক আছে হ্যাঁ হ্যাঁ so mobile phase is liquid as well as stationary phase is also a liquid. Very common example, paper chromatography. You know paper chromatography, what is the stationary phase? In paper chromatography, the moisture or the water, this is better you can say moisture content in the cellulose cell of the filter paper is a stationary phase. So interaction between liquid, so that's come under liquid chromatography. So there are four type of combination can be possible, but these three are the practical combination, whereas gas solid is not in use or obsolete almost. Next, based on the principle of separation or separation principle. Based on the principle of separation, again, there are different chromatography. Number one, adsorption chromatography. Number two is the partition chromatography. Number three is the ion exchange chromatography, ion pair chromatography, chiral or chiral chromatography, size exclusion chromatography, or gel permeation chromatography. Mainly 6 different type of principles are there. But again, among these 6, this number 1 and number 2, that means adsorption and partition. These are the, among these 6, they are the most important principle of separation. If I can say you in a percentage, almost more than 90% of the separation is based on these two, either adsorption or partition. Other this ion exchange, ion pair, chiral chromatography, they are having some specific application. Only specific type of components can be separated by these type of specialized technique. Okay, so we will be discussing later little bit on adsorption and partition after later on. Next is the based on the modes of chromatography, very important, normal phase and reverse phase. What is this? Again, we will be discussing later. That is the based on the combination of the stationary phase and mobile phase. All of you know it's a very important, specifically reverse phase. That also we will be discussing later. And also another classification we can discuss. It is not listed, but broadly we can say or we can classify that based on the mobile phase. Based on the mobile phase also we can classify the chromatography. Number one is the gas chromatography, where is the mobile phase is gas. So there is only one variant in that, only one gas chromatography, don't have any other variation. Number two is the liquid chromatography. Liquid chromatography means where the mobile phase is liquid. Where the mobile phase is liquid. So liquid chromatography having so many variant, like all the techniques we majority of the technique we discuss, paper chromatography, TLC, HPLC, then UPLC, HPTLC, all are coming under mobile liquid chromatography. Why? Because the mobile phase is liquid. That's why that that mobile liquid chromatography is very important and having so many applications. Okay, so these are the different types or the classification. Now let's see quickly. We will be discussing about the theoretical aspect. Okay, so theoretical aspect of chromatography, we will be discussing two separation principle. Earlier we have discussed partition and adsorption. These are the two important theoretical principle of chromatography. We will be discussing mainly these two because application of these two I told more than 90%. So first we will be discussing about the partition chromatography. So what is the meaning? You see, in partition chromatography, separation is based on the solute partitioning between two liquid phases. You can see the picture. Suppose one component, they definitely whenever we are discussing about the separation, there will be more than one component, definitely. But suppose component A and B, two component is there to be separated. So A or B, whatever the component, both will be distributed in two phases. You can see two phases means one is the stationary phase and one is the mobile phase. Okay, so partition chromatography, partition means distribution of a component in two different liquid or gas. One important thing you remember, whenever we are discussing about the partition chromatography, either the both the stationary phase and mobile phase will be either liquid, either both will be liquid or combination of liquid gas. That is one important thing. So liquid or liquid gas, this will be the combination in case of partition chromatography. Okay, this is one important thing to remember. So now you imagine one component, any one component you imagine, A or B, anyone, that will be same incident for the both the component. So that component to be separated, they will be distributed in both the phases. That means they are, you can see this is the partition. Imaginary partition will be there as these two phases are immiscible. These two phases should be immiscible. Suppose liquid, but that two liquids should be immiscible like oil and water. Oil and water, so definitely that component which is to be separated, they will be dissolved, certain portion of that component will be dissolved in the oil phase, as well as certain part of that component will be dissolved in water phase. Now let's see what happened. Acha. So this is one, it is the incident. First we are discussing the incident. What is partition? Partition means separation, that much only you remember. Partition means separation, so between two phases. So it is a imaginary, definitely it's a imaginary concept. So the component is partitioned in two phases. This is the incident partition. Next, what is adsorption? Adsorption, you know, very common thing. Adsorption means the retention of a liquid or gas molecule into outer layer of a particle. This is adsorption, you know. Activated charcoal. It is a component of a one small part of the activated charcoal, one particle of the activated charcoal. So the molecules are retained outside. That is known as adsorption. It is the opposite of absorption. Absorption means whenever it is coming inside, that is absorption, and if the components are retained outside, that is adsorption. Here another important thing I want to say, or I want to tell you, want to tell you that chromatography is a purely physical phenomena. Very important to remember. Chromatography is not a chemical phenomena. There should not be any chemical reaction, because if the chemical reaction takes place, chemical reaction is a irreversible process, whereas physical phenomena is a reversible process. So you remember, chromatography is a reversible process. Otherwise, why, the thing is that why we have to keep in mind, that's why our selection of the mobile phase, selection of the whatever the component or stationary phase also should be like that. They should be inert in nature, they should not be reactive. That's why we cannot use that concentrated acid or bases in as a mobile phase, because they are reactive. So either adsorption, 1 minute, 5 minutes. So either the adsorption or partition, the thing is basically a physical phenomenon. Okay, so that is a reversible process. That is the one important thing you have to remember. And why it is like that? Because if the component to be separated, they are reacting with the stationary phase or mobile phase, so we cannot separate that component. Ultimately, they will be reacting with that phases and they will be converted to other component. So that's why the component what we are going to separate, they should not be reacting with the either mobile phase or stationary phase. Say they can have an interaction, physical interaction like adsorption or partition, but that should be reversible so that the component can be separated in its original form. Then only the separation can be takes place, or the separation process can be completed. Until and unless if they are reacting, the process is incomplete. So very important thing to remember, chromatography is a physical phenomena. That means it is a reversible process. Okay, let's see next. So now how they are separated by these two phenomena. The important thing is that one thing, that is distribution coefficient. You have to know, or you have to remember. I think you can remember in physical pharmacy or physical pharmacy or physical chemistry, wherever you have studied so many physical characteristics of different component like surface tension, viscosity, etc. One important physical parameter is partition coefficient, or actually this is distribution coefficient KD. They are two type. One is partition coefficient, another is adsorption coefficient. So now, based on the partition coefficient or adsorption coefficient, the component are separated. How? Let's see. We will be discussing. Now we will be correlating the things. So what is the definition of distribution coefficient? You can remember. It is defined as the ratio of a concentration of a compound in two immiscible phases. I think you can see the last line. You can see it is defined as the ratio of concentration of a compound in two immiscible phases in constant pressure and temperature. That means a component A is distributed in two phases, oil and water. Suppose one part is distributed in oil, three part is distributed in water. So what is the distribution coefficient? 1/3. Okay, so that may be a fraction. Okay. So that value is known as distribution coefficient. Now, that distribution coefficient of a compound is very important for separation. Now let's see one example. A compound is distributed between equal volume of two immiscible solvent around, such as solid liquid, gas liquid, etc. Now you see, 2 minutes, 2 minutes. Now A and B is suppose we want to know the distribution coefficient of A and B. Distribution coefficient of the compound as per the definition, concentration of the compound in solvent A and concentration of the compound in solvent B. If there is a two different solvent A and B, so now the distribution, and also suppose two different components are there, X and Y. Now we can see X and Y. So distribution coefficient of X will be calculated by concentration of that compound X in concentration of that compound in solvent A and concentration of the compound in solvent B in constant pressure and temperature, whatever the value. So distribution coefficient of X, and same way we can calculate distribution coefficient of Y also, another component Y. Now let's see, because formula will be same for both the component. Formula is same. Now if the distribution coefficient of a substance, suppose X, between acetone and methanol is 0.5. What is the meaning? 0.5 means 1/2. 1/2 means 0.5. That means the concentration in methanol is twice as compared to acetone. খুব সহজ ভাষায় যদি বলি আমি, দেখো তার মানে 0.5 কখন আসবে, 1/2 যদি আসে উপরে 1 নিচে 2, then only it will be 0.5. So that means one portion is there in acetone, two portion in ethanol. That means the concentration in ethanol is twice as compared to acetone. So that ঠিক আছে তুমি চলো okay so up to this much you can remember and remaining portion actually I have a meeting also so I'll be completing and if any question is there or any doubt is there also we will be discussing in the next class only small portion was remaining how we'll be correlating now how this distribution coefficient helps in separation of the component because it will take some time okay so better we'll be completing this class here now next week maybe Monday or Tuesday again I will be taking one class in the meantime you go through this old these topics you have studied earlier also you can remember these things so তোমরা একটু দেখে রাখো সবাই কার কি স্পেসিফিক কোশ্চেন আছে নেক্সট ডে উইল বি স্টার্টিং উইথ দ্য কোশ্চেন্স এন্ড দেন we will be continuing that will be better okay because I think these are known things only one with a small touch only you can remember all these things okay so we are concluding the class here only ঠিক আছে তো সবাই